There is no specific code article that explicitly states the number of 12/2 Romex wires that can be bundled in a 1-1/4-inch non-metallic connector. However, several code articles relate to the bundling of wires and the use of non-metallic connectors. National Electrical Code Section 314.16b3 specifies that non-metallic cables shall not be bundled in such a manner as to exceed the allowable ampacity of the cables. National Electrical Code Section 392.14 requires that conductors be protected from physical damage when passing through holes in members supporting equipment. National Electrical Code Section 392.14b prohibits the use of non-metallic connectors that do not securely protect the conductors from damage. National Electrical Code Section 314.16b3 does not provide a specific number of wires that can be bundled, but it requires that the bundle's ampacity does not exceed the allowable ampacity of the individual wires. The number of wires that can be fitted into a non-metallic connector depends on the size of the connector and the wire gauge. As a general guideline, the following is a typical number of wires that can be accommodated in different sizes of non-metallic connectors. For a 3/8-inch connector, you can typically fit 2 to 3 12/2 wires. For a 3/4-inch connector, you can typically fit 4 to 6 12/2 wires. For a 1-inch connector, you can typically fit 8 to 10 12/2 wires. For a 1-1/4-inch connector, you can typically fit 12 to 14 12/2 wires. Based on the information provided, it seems like the inspector's concern is primarily related to the ampacity of the bundle rather than the bundling itself. To ensure that the bundle complies with code requirements, you should verify that the sum of the ampacities of the 12/2 wires in the 1-1/4-inch connector does not exceed the allowable ampacity of the wires. Typically, for 12/2 non-metallic cable, the allowable ampacity is 20 amps. Therefore, if you have 3 12/2 wires in a 1-1/4-inch connector, the total ampacity of the bundle is 60 amps, which is within the allowable limit. However, it's important to consider any other factors that may affect the ampacity of the bundle, such as the temperature of the environment where the wires are installed. If there are any concerns about the ampacity, you should consult with a qualified electrician to determine the appropriate number of wires for the specific installation. Let's delve deeper into each of these National Electrical Code sections to fully understand the requirements and implications. National Electrical Code Section 314.16b3 deals with the fill requirements for boxes. It outlines how many conductors, devices, and equipment can be installed inside an electrical box. The main goal is to prevent overcrowding, which can lead to overheating and potentially hazardous conditions. When bundling non-metallic cables, the section emphasizes that the ampacity of the cables must not be exceeded. This means that the combined current carrying capacity of all the cables in the bundle must be within the safe operating limits of the individual conductors. To determine the allowable ampacity, you need to refer to National Electrical Code Section 310.15, which provides ampacity tables for various conductor types and sizes. These tables take into account factors such as conductor insulation, ambient temperature, and the number of conductors in a raceway or cable. When conductors are bundled together, they can generate more heat than if they were installed separately. This is because the heat from each conductor can affect the temperature of the adjacent conductors, reducing their ability to dissipate heat effectively. As a result, the allowable ampacity of bundled conductors may need to be derated, meaning that the maximum current they can carry safely is reduced. The amount of derating required depends on the number of conductors in the bundle and the ambient temperature. National Electrical Code Section 310.15b3 provides adjustment factors for the number of current-carrying conductors in a raceway or cable. These adjustment factors reduce the allowable ampacity of the conductors based on the number of conductors present. For example, if there are 4 to 6 current-carrying conductors in a raceway or cable, the allowable ampacity must be reduced to 80% of the value listed in the ampacity tables. If there are 7 to 9 current-carrying conductors, the allowable ampacity must be reduced to 70%. And if there are 10 to 20 current carrying conductors, the allowable ampacity must be reduced to 50%. It's important to note that these adjustment factors apply only to current carrying conductors, which are defined as conductors that carry current continuously for 3 hours or more. Grounding conductors and equipment grounding conductors are not considered current carrying conductors for the purposes of this section. National Electrical Code Sections 392.14a and 392.14b address the protection of conductors and the proper use of connectors. National Electrical Code Section 392.14a requires that conductors be protected from physical damage when passing through holes in members supporting equipment. This means that if you are running wires through a metal stud or other structural member, you need to ensure that the edges of the hole are smooth and that the conductors are protected from abrasion or cutting. This can be accomplished by using a bushing or grommet to line the hole or by installing a cable clamp to secure the conductors in place. National Electrical Code Section 392.14b prohibits the use of non-metallic connectors that do not securely protect the conductors from damage. This means that you need to use connectors that are specifically designed for the type of cable you are using and that provide a tight, secure connection. Non-metallic connectors are typically used with non-metallic sheath cable, also known as Romex. These connectors are made of plastic and are designed to snap or screw onto the cable, providing a strain relief and protecting the conductors from damage. When selecting a non-metallic connector, it's important to choose the correct size for the cable you are using. The connector should fit snugly around the cable without being too tight or too loose. A loose connector can allow the cable to move and potentially damage the conductors, while a connector that is too tight can crush the cable and damage the insulation. It's also important to ensure that the connector is listed for use with the type of cable you are using. Connectors are typically marked with the type of cable they are designed for, such as non-metallic sheath cable or armored cable. Using the wrong type of connector can create a hazardous condition and may violate the National Electrical Code. In addition to these general guidelines, there are also specific requirements for the installation of non-metallic sheath cable in certain locations. For example, National Electrical Code Section 334.15c requires that non-metallic sheath cable be supported every 4 minutes, 1/2 feet and within 12 inches of every box or fitting. This helps to prevent the cable from sagging or becoming damaged. National Electrical Code Section 334.17 also requires that non-metallic sheath cable be protected from physical damage where it is exposed to mechanical injury. This can be accomplished by running the cable through conduit or by using a cable guard to protect it from impact. When installing electrical wiring, it's always important to follow the National Electrical Code and any local codes that may apply. These codes are designed to ensure the safety of electrical installations and to prevent fires and other hazards. If you are not familiar with the National Electrical Code, it's best to consult with a qualified electrician before starting any electrical work. Now, let's discuss some best practices for Romex wire bundling and connector fill. Firstly, always consult the manufacturer's specifications for the specific connector you are using. The manufacturer's datasheet will provide information on the maximum number of conductors allowed in the connector and any other relevant installation requirements. Secondly, when bundling Romex cables, try to keep the bundle as small as possible. This will help to minimize the amount of heat generated by the conductors and reduce the need for derating. Thirdly, use cable ties or other bundling devices to keep the cables together and prevent them from separating. This will help to maintain the ampacity of the bundle and ensure that the conductors are properly protected. Fourthly, avoid bundling Romex cables with other types of cables, such as data cables or communication cables. This can cause interference and may violate the National Electrical Code. Fifthly, when running Romex cables through holes in metal studs or other structural members, use bushings or grommets to protect the cables from abrasion. This will help to prevent damage to the insulation and reduce the risk of electrical shock. Sixthly, when installing non-metallic connectors, make sure that the connector is properly tightened and that the cable is securely clamped in place. This will help to prevent the cable from pulling out of the connector and creating a hazardous condition. Seventhly, Always inspect your work after you have completed the installation to ensure that everything is properly installed and that there are no loose connections or other potential hazards. This will help to prevent fires and other electrical problems. In addition to these best practices, there are also some common mistakes to avoid when working with Romex wire and non-metallic connectors. One common mistake is to overfill connectors with too many wires. This can damage the wires and create a fire hazard. Another common mistake is to use the wrong size connector for the wire being used. This can result in a loose connection or a connection that is too tight, both of which can cause problems. Another common mistake is to fail to properly support the wire. Wires that are not properly supported can sag or become damaged, which can lead to electrical problems. Another common mistake is to damage the insulation on the wire. Damaged insulation can create a shock hazard or a fire hazard. Always handle wires carefully and avoid bending them sharply or pulling on them too hard. Another common mistake is to make loose connections. Loose connections can cause arcing and overheating, which can lead to fires. Always make sure that connections are tight and secure. Another common mistake is to ignore local codes and regulations. Local codes may have specific requirements for electrical installations that are different from the National Electrical Code. Always check with your local building department to find out what codes apply in your area. Now let's consider a scenario where you are installing 3 12/2 Romex cables through a 1-1/4 inch non-metallic connector into a sub-panel. Each 12/2 Romex cable contains 2 current carrying conductors and 1 grounding conductor. The current carrying conductors are rated for 20 amps each. To determine whether the installation complies with the National Electrical Code, you need to consider the following factors. Firstly, the number of current carrying conductors in the bundle. In this case, there are 6 current carrying conductors, 2 from each cable. Secondly, the ampacity of each conductor. In this case, each conductor is rated for 20 amps. Thirdly, the ambient temperature. The ambient temperature is the temperature of the air surrounding the conductors. If the ambient temperature is high, the ampacity of the conductors may need to be derated. Fourthly, the adjustment factors for the number of current carrying conductors. According to National Electrical Code Section 310.15b3, the allowable ampacity of the conductors must be reduced to 80% of the value listed in the ampacity tables when there are 4 to 6 current carrying conductors in a raceway or cable. In this case, the allowable ampacity of each conductor would be reduced to 16 amps 20 amps x 0.80. Fifthly, the total ampacity of the bundle. The total ampacity of the bundle is the sum of the ampacities of all the conductors in the bundle. In this case, the total ampacity of the bundle would be 96 amps 16 amps x 6 conductors. Sixthly, the rating of the overcurrent protection device. The overcurrent protection device is a circuit breaker or fuse that is designed to protect the conductors from overloads and short circuits. The overcurrent protection device must be rated at or below the ampacity of the conductors it is protecting. In this case, the overcurrent protection device should be rated at or below 96 amps. Based on these factors, you can determine whether the installation complies with the National Electrical Code. In this case, the installation would likely comply with the National Electrical Code, provided that the ambient temperature is not too high and that the overcurrent protection device is rated at or below 96 amps. However, it's always best to consult with a qualified electrician to ensure that the installation is safe and compliant. It is important to recognize that local electrical codes can differ from the National Electrical Code. These local codes can be more stringent, offering additional requirements or amendments to the National Electrical Code. Always check with your local electrical inspector or building department to determine which codes are in effect in your area. The local codes may have specific requirements about the number of conductors allowed in a particular size of conduit or connector or derating factors that need to be applied. Understanding these local requirements is vital for ensuring code compliance and safety. Also, bear in mind that electrical codes and regulations are periodically updated to incorporate new technologies, safety standards, and best practices. The National Electrical Code is typically revised every 3 years, and local codes may also be updated on a similar schedule. Staying informed about the latest code changes is crucial for electrical professionals and anyone involved in electrical work. This can be achieved through continuing education courses, industry publications, and by actively participating in local code-making processes. Remember, while the National Electrical Code and local codes provide essential guidelines, they cannot cover every specific situation. There may be instances where you encounter unique circumstances that require engineering judgment and careful consideration. In such cases, it is advisable to consult with a qualified electrical engineer or other expert to ensure that the installation is safe, reliable, and code compliant. The electrical industry has witnessed significant advancements in wiring methods, materials, and technologies. It is essential to keep up with these developments to ensure that electrical systems are installed and maintained using the latest and most effective techniques. For example, new types of cables with improved insulation and higher ampacity ratings have been introduced, offering enhanced performance and safety. Similarly, new types of connectors and fittings have been developed to simplify installations and improve reliability. Staying informed by these innovations can help you make better decisions and improve the overall quality of your electrical work. In conclusion, understanding the National Electrical Code requirements for Romex wire bundling and connector fill is essential for ensuring safe and compliant electrical installations. By following the guidelines outlined in the National Electrical Code and considering the factors discussed in this explanation, you can avoid potential hazards and create electrical systems that are reliable and efficient. Always remember to consult with a qualified electrician if you have any doubts or questions about electrical work. Electrical safety is paramount, and it is always better to err on the side of caution. By continuously expanding your knowledge and staying up to date with the latest codes and technologies, you can contribute to a safer and more reliable electrical environment.